In this lecture, I will continue with the problems of atomic structure and I will solve today two more problems. Now in problem number 7, you see it is given what will happen if a hydrogen atom absorbs 13.6 electron volt amount of energy in ground state. Now for solution of problem 7, we can write the energy of hydrogen atom to be minus 13.6 upon n square electron volt. This is the energy of an electron for an hydrogen atom. Now for the ground state, we will have, this is for the nth orbit, that is energy of hydrogen atom, energy of an electron of an hydrogen atom revolving in the nth orbit is given by this expression. This is a result of Bohr's theory. And for the ground state of electron, we will have E1H equals to 13.6 by n square, that is 1 square. It will give us this value. Now when this atom absorbs 13.6 electron volt amount of energy, let us see what happens. So we assume that E is the energy of the atom after absorption of this amount of energy. So what will be the value of E? It is E1H plus 13.6 electron volt. Now we put this value. This is coming from the external source. This amount of energy is coming externally. So we have minus 13.6 electron volt plus 13.6 electron volt. So energy of the electron will be 0 after absorption of this amount of energy. So what does this imply? This will imply that in the hydrogen atom, this is nucleus where we have only one proton, and this is the first Bohr orbit where the electron is revolving, and here the energy is minus 13.6 electron volt. Now after absorption of this amount of energy, its energy will be 0, that is it will leave the atom. It will go to that place, that distance away from the nucleus where the field of this positive charge will not work. So let the field of this positively charged nucleus work up to this distance. So electron will come here. So beyond the field of this nucleus. And this distance will be referred as the infinite distance from the nucleus. So the electron will have no potential energy. Since it is not within the field of this positive charge, so no attraction, so no potential energy. And there is no repulsion also, since there is no other negatively charged particles present at this place. So it is both devoid of any kind of attraction and repulsion. So the potential energy will be 0 here. Now this electron will remain at rest after getting out of the attraction field, that is after getting out of the atom, it will remain at rest, since kinetic energy will also be 0. So the total energy will be 0. Now what does this imply? This imply that the hydrogen atom will ionize. So this is H atom. So we have a proton here and the electron here. revolving around the nucleus, and it will ionize after absorbing 13.6 electron volt amount of energy. So it will be only proton. So this is the ionization energy. This plus 13.6 electron volt is the ionization energy of hydrogen atom. So this will happen to the system. Now we come to problem 8. In problem 8, a problem is given which has its answer within the Heisenberg uncertainty principle. So the problem is accuracy of measurement of velocity of an electron moving with velocity 600 meter per second is 0.005%. Now find the accuracy of locating its position. So this is the uncertainty principle problem, and the velocity of the electron is given and the accuracy in measurement of that velocity is given. So this accuracy will give you the uncertainty in velocity, and you have to find from it the uncertainty in determination of position, that is accuracy of locating its position. Now as per uncertainty principle, we know that the position and momentum of a quantum mechanical particle cannot be determined simultaneously with precision. So an uncertainty will be associated with both the position and momentum for a quantum mechanical particle. So we will have del x del p greater than equals to h cross by 2. Now for the problem, we take the lowest possible value of uncertainty product. So we will deal with this equation with this equality, not with this inequality, and it will be h by 4 pi, since h cross equals to h by 2 pi. So h cross by 2 will be h by 4 pi. Now the uncertainty principle, that is the product of the uncertainty of position and momentum, is thus del x del p equals to h by 4 pi. Now what is this uncertainty in momentum? It is mass into uncertainty in velocity. Since there is no uncertainty in mass and uncertainty is associated with the velocity, so this del p, that is the uncertainty in measurement of momentum, will be formulated as or expressed as mass and the product of mass and the uncertainty in velocity. So it will be h by 4 pi. Now what do you have to find out? You have to find out del x. So del x will be h by 4 pi m del v. So we take this m del v to the right hand side. So we will get the position uncertainty. Uncertainty in position, that is accuracy of locating the position of the electron. Now we have to carefully put the values of these things. So h is given by 6.626 into 10 to the power minus 34 joule second. It is a Planck's constant, and 4 pi is, you can directly put pi in calculator or you may take it as 22 by 7. It is a good approximation. And for mass we have the value 9.11 or simply 9.1 into 10 to the power minus 31 kg. This is the mass of the electron, and we have the uncertainty in velocity. Now what is the uncertainty in velocity? It is the accuracy in measurement. So it will be 0.005% of velocity. So it is 0.005% 0.005 by 100. 100 counts due to percentage into velocity, that is it is 600 meter per second. Now this 100 and 100 will cancel out, so we will have 5 into 6, it is 30. So we will have 30 by 1000. See, this 0 will cancel, and this 5 into 6, it will be 30, and 0.005, so it will be 1000. So it is 3 by 100 meter per second. That is the uncertainty in measurement, uncertainty associated with the velocity. So we put this here, value of del V. So it is 3 by 100 and it is meter per second. Now we take .626 here, and this 4 into 22, it will be 88. We take 7 in the numerator, here it is 9.11 into it is 3. Be careful, we take this 6.626 here, this 7 will go to the numerator, this one 4 into 22, this is 88, this is 9.11 and this is 3. Now this 100 and this 10 to the power minus 31 will give you 10 to the power minus 33. This is 10 to the power 2, so it will be 10 to the power minus 2 here in the numerator, so it will give you 10 to the power minus 33. Now when it will come up, it will give 10 to the minus 34 plus 33, it is 10 to the power minus 1. Now come to the unit. This joule second, you see, this joule is Newton meter and Newton is kilogram meter per second square. So Newton is kilogram meter per second square, and we have another meter here. So Newton into meter, that will give you joule, and another second from this joule second, and this second inverse will come to the numerator and it will give you square. And what you have in the denominator, in the denominator we have kg here and meter here. So this will cancel out, meter will cancel out, kg will cancel out, and you will have meter left. So that must be, since we are determining the position of the electron, uncertainty in position of the electron, so that must have dimension of length, that is meter. Now we have to calculate the value, so we need calculator. .626 into 7 equal to divided by 88 equals to divided by 9.11 equals to divided by 3 equals to. So we get 0. So we get the value of del H to be 0.019285 into 10 to the power minus 1 here, and we will get meter here. So this is the result. Now we have to express it properly. So it is our del x equals to, we must represent the point after one digit, so it will be 1.9285 into, here we take this point over here, so here it will give us 10 to the power minus 2, and 10 to the power minus 2 and 10 to the power minus 1 will be 10 to the power minus 3 meter. So this is the answer, and we have the accuracy of locating the position of electron, that is the uncertainty in position, will be 1.989285 into 10 to the minus 3 meter. So what the uncertainty principle says? It says it is impossible to determine the position and momentum of a quantum mechanical particle simultaneously with precision. You cannot have both the values with 100% accuracy. A certainty in one will introduce uncertainty in another. So if you have an uncertainty with the velocity determination, that is in the momentum determination, it will obviously be associated with uncertainty in position. And the product of the two uncertainty has a minimum value which is h by 4-5, which you cannot reduce it to 0. So the uncertainty cannot be 0.